This becomes non-functional because now the solution becomes a square root of the solution. For example, the solution of the square root of 0. It's because
this is my paper. Sorry, my laptop and my center. We try to discuss the day of reanalysis of two swimmers problem as frequent model of Michelson interferometric experiment, demonstrating that transversal path is not an isosceles but a right triangle, and the race will end in a tie. I am Ioan Has, and Aurelian is here, and Simona is in Sibiu, in Romania. An outline of this article. General presentation of physical model PM, we tell shortly, of Michelson experiment, ME shortly. Description of some physical models from literature. Finding and observation on previous models. Literature. Correct reanalysis of the two swimmers in the physical model PM. This will be done in two phases. Correct reanalysis in the W frame, in water frame, and correct reanalysis in B frame, in block start frame, or in a bank frame, and some conclusions and consequences. As a general presentation of physical models, I don't say all the details because many of us maybe know about this model of Michelson experiment, which must be created by two swimmers, by two boats, to plane, or to sound, or other sign. But generally, the swimmer must have the constant speed on the river with the other constant speed V respectively C. First swimmer S1 shortly say, must take the path L1 from two parts, L1 prime and L1 second, where the distance L1 prime is oriented opposite the river flow. The second swimmer, S2, will take the path L2, where the initial distance L2 prime equals L1 prime, but is perpendicular to the river flow direction, and also to the direction of first swimmer.
Can we see the figure 1? Can we see the figure?
Figure 2, yes, on page 7 for information. This is this is figure 1, with the distance is L1 for...
It's figure 2.
No, figure 2 is necessary.
This
This
figure 2.
is necessary, figure 2. No, 1 is... here we have distance L1 from the first swimmer and L2 for the second swimmer. And this is the initial position, an intermediary position when the swimmer 2 arrive in point A2, and the final position when they return to the bank or to the dock start. We rewind to the page 2. No, that's the one. I must emphasize that the condition correct for the swimmer's contest is the orthogonality from their initially pass, from L1 prime and from 2 prime. This is necessary because in Michelson experiment, the setup was also the 2 rays of light to be orthogonal. And one must remark that we must make clear what is the frame reference, which is RF. This because we have possibility of infinite reference frames, but 2 reference frames is recommended. The water reference frame and the bank reference frame. Water is equivalent to the ether in Michelson experiment. In our analysis, we indicate especially any reference frame from the tool. But in precedent description, encountered in the physics literature, one demonstrates that the time of swimming the transverse road is shorter than longitudinal, and as Doi wins the race. This becomes like a myth for many young generation of high schools or college graduates. In the next section, we will demonstrate that this race will run in condition of fair play. Both swimmers will reach the start point at the exact same time. Description of some physical model in literature. So, in works of Freud, he states when the boat is sailing at right is the case of the boat, not steamer. Sailing at right angle to the bank is the turn is both slightly upstream. This is an indication that it's not orthogonality between two paths. David Harrison's work, says, now the raft and mortar are being towed to the left. In this case, the race will no longer be a tie. Precisely. In fact, no too hard to show that we want to win the race. This is the conclusion of Harrison. Also, Michelson have the same conclusion. I don't insist here. I want to mention especially Michael Fowles, who says the swimmer going across the flow is trickier. It wants to simply to aim directly for the opposite bank. The flow will carry the swimmer downstream. To succeed directly across the swimmer must actually aim upstream. Only direction orthogonality if it's aim upstream. This is the original figure of the Fowles. And here mention is a trickier. Although Bernard Jaffe have the same presentation, but again, the particularity is not respected. George Gamow directly specified that the delay is due to the fact that the boat, in order to go from boat bridge 1 to boat bridge 3, it must advance slightly sidewise. That again, not orthogonality. Chubotaro, EA, says the boat movement speed from a sound signal with sound speed v may also be determined by having a reflecting area. From figure of their work, one may determine the time also under this expression, where we can see that again is not respecting the orthogonality. Finally, with this example, Thomas Diri say to compensate boat 2 has to head into the current upstream at a certain angle. Again, not disrespecting the orthogonality. Such an analysis of PM model, in which the lack of orthogonality in the starting direction of the S2 may comprise all published works on the above subject about PM models known by us. Finding and observation on previous PMS. We know that every previous description must be some other. Which are analog for the Michelson experiment, contain an error in which the complex similarity between MT and PM is disregarded. This refers to the direction of initial path of L2 prime, which is allowed to S2 to deviate from orthogonal direction to outer speed direction, because as we do start at a small angle beta against the exact orthogonal direction. Such a path constitutes a trick and a non-fair play towards S1. Note that angle beta is not explicitly stated to as 2, but indirectly this constitutes a trick, because it is said that S2 should aim at a point C from the opposite bank, but situated outside of orthogonal direction. But this inclined aiming of the initial path is impossible within condition of the interferometric experiment of Michelson, because the opposite mirror M2 does not include reference marks for included light path, which does not have the sentience in order to consent to a trick, and thereby in Michelson experiment it starts path L2 prime exactly at 90 degrees. And in PM experiment, on the other side of the river, no personal or no mark exists to indicate to S2 the direction inclined with angle beta. In the physical model, if the physical model PM will be deployed in the condition of an official race or even an Olympic contest, the organizers will not allow such deviation. This means that swimmer 2 should also start orthogonally on the block start, thus perpendicular to path L1 prime. The notice of Michael Fowles wrongly characterizing the swimmer 2 as a trickster, we must agree with Fowles. This is because swimmer 2 benefits from the information which is not allowed in the fair play contest. And also, this is not possible in the Michelson experiment. The basic rule in such a contest, as understood by layman or any person, is that both swimmers must start from the block start in orthogonal direction between them, just as light in a Michelson experiment where the splitter of two rays is disposed exactly at the 45 degrees. The two rays emerge at 92 degrees exactly. As observation, we define such deviation from orthogonality as essential error in the involved analysis. We must emphasize that the above indicated error in PM, physical model, was also taken over by Michelson in the analysis of his experiment, but here we'll limit our analysis only to that figure, not to the analysis of Michelson experiment. Now, the correct reanalysis of the two swimmers in the physical model. This analysis is based on the observation from previous section, where the start-up mode as DOI must observe the rule of fair play. This means that S2 should not benefit before startup of the prior knowledge of the speed of river, not of the necessary inclination of the angle beta. Should start according to the inference and unanimously accepted rule by the audience in such context. The two swimmers should start from the group start at two orthogonal direction between them. However, an aspect that should also be specified here is very important, is about the reference frame, RF, shortly, of the space to which the movement or relevant bodies are referred. This must be very clearly established. In the case of our PM, of the two swimmers, the most useful reference frame shall be the water attached frame, moving with the speed V against the bank and the block starts. This specification of reference frame is not made in any previous work about this physical model, or swimmer, or boat, or plane, etc. For this reason, when both references frame are involved, misunderstanding and error in the analysis of the phenomena may ensue, and the error of start direction of S2 has systematically slipped in. In this analysis, we will indicate which RF is adopted and even clearly marked it on the power figure. We must mention that for the reference frame of time, we have a unique reference time with the characteristic of classic time. Correct reanalysis of PM. Generality. The correct path in PM for two boats was described by us previously in some our paper. We can find at the end of this paper. But we rediscuss this path there for the swimmers. In figures 2 and 3, the adopted reference frame is VYWF. With the axis Ioan reversely to water speed. Here point 201 was taken as point as coinciding with the block start VS. In this PL, the water flow speed have direction to the left, and the block start and the river banks will shift to the right in this case, as we see in the figure. Now, analysis of PM in case of crosswise direction. This is the most important analysis of the crosswise direction. In let's go to the figure. In this case, in the crosswise or transversal direction, the swimmer 2 starts here and right here at A2, and when it returns to the opposite bank, we can observe the new position of the block start, and he can swim with the adequate velocity attained in opposite band, the block start. When it starts here, the block start is here, but when he arrives on the opposite band, it is here. And you see that this path is not an isosceles triangle, but is an rectangular triangle. We pass to, this is the consideration of what I explained on the figure, not repeat them. We must calculate the times. Okay. The times we can calculate from the figure 2, and we have some geometrical position of the swimmer, and from right triangle O1, A2, O2 result this expression, and making the calculating, I don't insist about them because it's not complicated, but must be very careful. And finally, we obtain for time 2, which comprise the both paths, this expression 2L2 under C1 under alpha squared, where alpha is a well-known expression in the relativity theory. In longitudinal direction, must return to the figure 2. In the longitudinal direction, the path 1 for swimmer 2 go from O1 to R to Y. This is the returning goal, and to the returning path L2 second, you must make this distance, and we can calculate also this time for swimmer 1. Yeah. Here and here. Similarly, with calculation for the swimmer 1, we obtain for the swimmer 2 on the next page this expression for swimmer 1. We see that it's exactly the same expression like for swimmer 2. 2L1, excepting the length of race. This is L1 and present was L2. In case of L1 equal L2, this is obligatory, we obtain that T2 and equal T2, T1. And delta T is 0. No difference at the right wing of two swimmers on the block start. So this race will end in the tide, as we demonstrated. No winner yields this race, just hypothetical, because there are no data of proof that such race would have been practically performed. And winner 2 was a winner. But indeed, a real such contest will be clearer for the disputed result. However, any intermediary starting direction of swimmer 1 inclined to the bank with angle alpha different from 0, but with swimmer 2 starting also at the orthogonal direction will give the same result. We must make the correct reanalysis of the physical model in a DF frame of block start frame. In this case, the system of references will be attached to block start or to the bank, and the path of starting with the number 2 will be this. When only water flows to the left and all the installation is fixed, then the number 2 will make this path double line inclined with the angle width. This is the same phenomena here when it number 2 arrive in this point and return with the eyes to the block start. He can make inclination of his speed, also with combination with the speed of water, C plus V, to give a vector on direction A to prime O. And in the same reference frame, for swimmer 1, the path is not so complicated. Are stable also the block start, also the returning wall, and the path will be this double line. And because the phenomena is the same in the both reference frame, it is not necessary to calculate again the times from figure 4. The time will be necessarily the same, and no need new calculation. So, yes, and finally arrive at some conclusion and consequences. From above presented the situation of the physical model, the path taken by swimmer 2 in crosswise direction of river flow must take the shape of a right triangle. This disagrees with interpretation for many other authors and Michelson himself, who considered the isosceles triangle to be the correct path, probably also on water frame, because no one specifies the reference frame in all analyses, and I am not surprised, because this must be a cause of the error, because not was clear what is the reference frame, or is water, or is band. When considering the right triangle of the path covered by S-GOI in beefy frame, 2 times of swimmers 1, 2 shall be equal. This means T1 equals T2, and the race ends in a tire. In beefy frame, in bank frame, the transversal path takes the shape of an inclined double line with angle beta, but the time to T1 and T2 must remain the same as the precedent frame. As a consequence, utilizing the isosceles triangle for the transversal path results in erroneous analysis. This is valuable also for the swimmer contest, also for Michelson experiment. Not isosceles triangle must be considered. Clearly, this result should also be applied to other similar experiments, including laser, master, or other agents, which is similarity with the ME experiment. So for the presence of, my conclusion, the presence of the ether remains a possibility even after the ME experiment correct reanalysis. And the ether should not be removed from physics, as Einstein did based on his interpretation of ME. Based on our above result, it is justified in physics, terrenos, and future as SST, special relativity theory, and instead to introduce a modern real ether in physics, as we already done in some published papers, including a new gravitation theory, which can remove or replace the GR, general relativity. And so in presence of the ether, many unexplained phenomena ranging from quanta entanglement And because the atmospheric electricity at large scale and the so-called dark matter in astrophysics and other such phenomena and so-called black holes, including after us, Big Bang, and will receive their correct physical explanation. Thank you.
We'll forego question time.
I was a comment, short comment.
We are 25 minutes. We're overrunning already quite a time. If you can do this question time in private, please. And we'll get back here at 6. Now it's 16:54, so it's now 5 to 5. We're back here at 5:30 as originally planned.
But I would still also like to ask a question, but I am not offended if people want to get coffee in the meanwhile.
Okay, let's do it this way. Those who want to go out and take coffee, please move out. And then...
Okay, so I have a comment because I'm one of those that my experiment and I want to explain something about this. Please, I want to ask you a comment on this.
And it's going to be the following so that we can talk.
It's just information for you and for everybody else. Your analysis of the right triangle was a mistake made by Michelson himself in one paper. He made that an error right there in the 1981 paper when he made the first experiment in Portland when he was working with Then Lawrence mentioned to him that was a mistake, and he corrected and he introduced the analysis of the isosceles triangle. So the mistake you're making is the following: when you have the Michelson model experiment, the green lines are not aligned. They are just because they are in dispersion on the mirror. And so, it doesn't matter that someone makes a trick. It doesn't matter that there is a dispersion in the reflection. Why does it? Because there is a mirror dispersing it.
Shall I try to explain it in one sentence? So I'm a laser physicist. I do interferometric for my bread and butter all the day. The point is that it's not above 90 degrees. The point is that you make an interferometer that actually brings the sort of orthogonal beam back exactly to the beam splitter. So you align this beam splitter, or like it's almost 90 degrees, and then you align that mirror so that it comes exactly back. Which actually gives not a 90 degree, because if there's an ether, that will be actually, in that frame, it will be not 90 degrees. But then if you rotate the whole system, it will be the other way around. So that's actually what is going on. But your first approach to the problem was completely correct. So the things that you said were right, because people say that it's 90 degrees and so on, but this is actually what is going on. And so you still have to reanalyze your results to make them sensible for the Michelson modeling experiment. So this is not the end of the story. That's what I'm saying.
But this is not the end of the story, because I checked the experiment. I made the experiment for 2 years. And so I checked the effects of daily rotation of the Earth, because my experiment was stationary in the laboratory, and so the rotation was by the Earth, and I did that during 2 years, so I had the opportunity to look at the rotation around the Sun. So I did put my reference frame not here, I put them back there in Earth, in the fisher stars, and I corrected them. And then I calculated the inverse problem. I calculated what would be the speed of the Sun towards that absolute space down there. And I got it and they were different from zero. My calculations are explained in analysis physics than the theory, but the results are explained in San Diego and in China. For the two solutions I got two different, one for the down, one for the down solution.
But that's now about the analysis of the Michelson wall experiment itself, not about what Ioan is trying to do.
He said that nobody has to mention about the reference frame. Yes, I did. I did correctly.
Thank you.
I once modeled that Michelson wall experiment on the assumption that the ether is at rest in the frame in which the microwave background is uniform.
Another
Take that, but it doesn't. You also say it's going. Okay, continue.
So the result was that the Earth, of course, is turning into things. And the one thing you want to know is, so when the Earth, when the plane of the experiment is not, when the velocity vector of the Earth through is not in the plane of the experiment, you get the maximum signal. Okay, so the actual experiment is done with this plane rotating around like this. So you have to correct for that. And when I did it with these assumptions, calculated it all, I got almost exactly the numbers that he needed. That he saw for the observation.
Okay.
In that case, you mentioned it.
So no, I'm more this only about that he's complaining about that people do not align the situation. And he's right. David, I think he misses the point as well. But they also the thing is that if you align an interferometric that you want to get exactly like what your rates will be, that's the idea of making an interferometer, that you do not make something that goes like this and then it goes like that. You don't want to make any triangles. And so you align it, you direct it forward in whatever direction it is going, so it will build that maybe or maybe I suppose it's there. You will align this thing is this mirror here actually determines basically that. So you make sure it falls on the mirror, so you position the mirror so it's there. And because your cross eye you can't see, it's actually already going in a strange direction. But you then put your mirror there and you start into your newsletter. So that's also good. It doesn't have to be 90 degrees.
Well, I don't do it before.
You make sure that your beam is exactly aligned with that. So you do not have a drive in that frame. So then you don't have to wait for a year, you don't have a year to get a big
my family is
just turn your whole system around, and if there is an event, then already your beams will be aligned. So that's the consequence of it. So now, can you measure that? So it's just that's it.
The thing, I know that you made interferometers and it goes all the way around, but the thing is,
I'm only talking about the alignment, not about any speed differences or anything. It's just the beam alignment, which is of course related to the speeds because otherwise,
So my case is going another one. I like to tell the general public is just you have a large parking lot. That one. I want to here. The light is just on the side with a mirror and one parking lot with a mirror. They move relative to the parking lot to the speed parallel. And so it's very clear that there is no incident. Not easy at all. So why so they move there. And it's so clear that if you send a radar or someone, it never will reach. Because of it, so actually you have to send it right at the beginning. Like this. And that is why you do the calculation of the interferometer.
But the point is, you have no control. You have no other control than just the beam split that you have, really. Really, you distort it somehow, and you don't know in what direction the beam is actually really going to go. But you sit, and it doesn't matter. It really doesn't matter. But then you put your mirror there, and you put it exactly back there, because that's the thing you can see. But it's the only thing you can properly see.
But you calibrate the splitter. You do this calibration.
Yeah, but then you also have to realign your mirror.
To see it.
Yeah.
You have to one of them.
Yeah.
I done this on the other one.
So for the swimmer, in case of the swimmer, of course, you can say you have to swim to a certain target and come back.
Yeah.
But this is a thing that's an action by the swimmer that's independent of the water level. And here, in the Michelson water experiment, it's a consequence where it goes, or where the ether is going, and it still comes back because you have realigned it. With a mirror, that automatically takes that action, whatever is happening. But then, if you turn around the system, it will not be aligned, because then the ether will go and take it in a different direction. So your beam will actually make a triangle instead of being exactly aligned. That's what's going to happen, and you will see it in the fringes. Because then you have missed on that beam, so your bullseye is not where it should be. See the fringes. So that's how it really works.
Actually, there is a delay also because of what?
I've not measured it. I've not done it. I've not done the experiment.
No, I have done the experiment because it took me a long time. Because I did the experiment
because it's very subtle. It's very subtle. I come to my colleagues that I have to do this, and then they adjusted. Yeah, because in practice you have to make a very rigid thing because you want to rotate your experiment, and then and thermal fluctuations and everything. I mean, the real thing is just
that the whole effect is only
because
the relative velocity zero.
Yeah.
You see, I did not
The beam
rotate
that you're sending out isn't a parallel beam. It's a spherical beam.
You have to do it for that too. So you have to take a wide beam and you have to.
The point is, because the whole goddamn thing, when you get back, because it always did the variation was emergence.
Exactly. So you have to correct for that.
Yeah.
The best thing is then to sort of make a beam that has a waist on the mirror, at the far mirror, because then it goes back nicely. So there are all sorts of tricks on all that. I can discuss for a while. Because I'm not joking. I mean, I was not. I have no idea.
Your experiment doesn't. The experiment you did doesn't.
No, I don't do that experiment. I've not done that. But I do align lasers. I know what the true thing that you do when you align the Michelson the Morley experiment is a different thing than what they say in the textbooks. It's also a different thing from what he is saying. That's what I'm saying. Because you're not aligning 90 degrees and you're not instructing the photon to go anywhere. You're aligning this the mirror takes it back to the viewfield. That's what it's
The next speaker.
No, I don't know.
because it doesn't.
Well,
What I find, I don't know.
The question.
Right.
With gamma 5.
I thought that it.
So,
By the way,
Thank you for your talk.
If I want to be ready, you change the nature of the equation. Because the first four gamma change.
Sorry?
They don't change the different forms.
So.